Hi students, welcome to Magnetic Fields Other Applications. That was Matt LeBlanc. So in this one we're going to look at quickly look at magnetic fields and how they're used for various things. Let's get a go. Now, a couple of just things for interest's sake and some are actual more practical applications. This was one we found a few years ago, which is called ferrofluids. Basically, it's a suspension of nanoparticles, and the nanoparticles are little iron oxides. So they're so small that they can be kept in suspension by coating them with something that makes them very attractive to water. And so because they act like little magnets, this liquid, when you put it with a magnet, here's a magnet here, the fluid flows along the field lines, and a line forms these shapes that relate to the magnetic field lines. And there's a whole lot of videos here. This one's ferrofluids in test tube. This one's ferrofluids short. These are on your OneNote. Then there's two that relate to some sculptures. These were discovered by some physicists / chemists, and then some sculptures put it to some artists put it to some interesting uses, to make some kinetic sculptures that move and things. And you might just think that's interesting, however it's actually found a practical use, and that's where they use magnets and a ferrofluid to actually seal casings between shafts, and so and to also lubricate that shaft, so they can by having a magnet attached or around the shaft and then a ferrofluid, the ferrofluid doesn't go anywhere else but stays near the magnet, and then can actually lubricate and seal the shaft, because sealing shafts is quite a technical thing, especially if there's pressure and stuff on the other side. These ferrofluids are also used, or sort of adapted to be used in oils, where they're added to oil, and so they actually make the oil stick to magnetic parts of the engine, and therefore they coat rather than just being under the influence of gravity and things like that. Another use are speakers, and speakers can be converted into microphones, and we'll talk about microphones when we do electromagnetic induction in the next topic very shortly. But this is a cross-section through a basic speaker. What you'll have is your magnet, usually a horseshoe or a round magnet, so that you get a strong uniform magnetic field, in this case here and here. This is an interesting shaped magnet, and inside that the field you have your coil, and we'll show another picture shortly, and that coil has the current flowing through it, and that current is sent from the amplifier, and that current varies according to the music that you want to make, and the amount of current will then, because you have a current carrying wire in a magnetic field, it experiences a force, and that causes these coils to move in a certain direction, and it also determines how fast they move as well. Now these coils are attached to the cone, and this goes out, and that's the bulk of the actual speaker. So the cone moves backwards and forwards depending on the current that's sent through the coil, because the current will then experience force, and that's how you get the sound, by moving the cone, pushing the air backwards and forwards. And if you touch a speaker you can actually feel that happening. Now a microphone's pretty much just the reverse of that, but we'll talk about that when we do electromagnetic induction. Here's just another one. You send a signal in, and so the signal varies, therefore the current varies, therefore the force varies, and therefore the cone moves backwards and forwards to produce the sound. Maglev trains, or magnetic levitation trains. This is where things move, trying to reduce the amount of friction by levitating and using what's called an electromagnetic force, but also they don't just use it to levitate, they can actually use the interaction of magnetic fields to propel the vehicle for the train. Can be much faster than wheels because less vibration, less bearings, less things like friction, all sorts of things that can happen, and they can reach up to 500 kilometers an hour. And there'll be a video on the OneNote showing one of these passenger trains travelling that fast, which is as fast as a jet plane. And so these are used for commuter trains between large cities, for example in Japan and China. This is the current record, I think 581 kilometers an hour, set in 2003. They really just sit on about 500. They don't want to break records because that's not their job. And this is what they look like. They use air brakes as well, because that's just another way of saving energy. And how they work, the ones that actually propel themselves, they have these coils in the tracks, and then they have coils in the trains, and they turn on the coils as they move, and they also use coils to lift the train up off the track, and then they have these other coils to actually keep the train positioned perfectly so it's not rubbing against any of the guides or anything, and so you get a very smooth, quiet motion. And these are what the tracks look like. They have these coils and they turn off, and these are propulsion coils, so these can change direction depending on whether they're pulling the train towards them or pushing them away from them, and they're switched on remotely by the train actually travelling nearby. And so this is the real pixelated picture of how it works. The bluey purple is a north and the red is a south, so this case that these are attracted to each other, and this coil's turned into a north, so it's repelling, but it's also attracting this south, and so the interaction of these coils causes the train to move to the left. And I've got a couple of videos here. The first one is of the fastest train, that will be on the OneNote, and the second one is, let's just hover the mouse over it, is the Maglev, which I think is a promotional video about from a company that wants to sell these magnetic levitation trains as a commuter option, maybe between the airport and the city, and it has lots of information on how they work and how they bank the corners and things like that, so fairly interesting. And if you go to Europe, they're used on small scale, not necessarily travelling at 500 kilometers an hour, but they're used for shorter distances, whereas in Japan and China they're being used for longer distances and travelling quite fast. Now we got magnetohydrodynamic propulsion. There was an old movie called The Hunt for Red October, in which a famous quote is, "Now they will tremble again at the sound of our silence," and that's because this advanced Russian submarine had turned on its silent running, which is supposedly a magnetohydrodynamic propulsion, and therefore no one could hear them. And what it is fairly simple. Basically, if you have a conductive fluid, so anything that can conduct electricity, so something like salt water, liquid metal or plasma, if that's exposed to a magnetic field, an electric current at right angle to each other, so exactly what we were talking about, combined magnetic fields and electric fields, the interaction of the magnetic field and the electric field propels the fluid in a certain direction, and usually perpendicular to the other two axes, so we can get a push, and the fluid itself is part of the engine. So this is what an experimental one looks like. This is it on the water. It was built, didn't achieve very great speeds though, because there's lots of energy lost. It's not as efficient, or it wasn't as efficient as they thought it would be, and I don't think it's gone any further than this prototype. However, this principle is being used in lots of things, including electric power generation, and also working with in terms of atomic particles. You can make it in nuclear fusion as well as a way of generating electricity. So I'm just about to bring up a diagram here. That's a whole lot of words. Here we go. So this would be a typical way of generating electricity. We have a conductor moving through a magnetic field, and it could be a vapor or a plasma. So in a nuclear reactor, that's how they use steam, but the steam is a bit radioactive as well, and that generates your electricity. And what they're thinking here about MHD is you have the plasma, you have your electric field there, and your magnetic field there, and the plasma flows through there, and it actually generates a current between the two plates, and that's getting rid of. So it's actually more direct than using a turbine, and it should be more efficient. But still, it's in the experimental phases. So certainly using it as a motor didn't work. And if you go to YouTube, you can find some people that have made little model motors using the principle, and they really only putt along very slowly. Another example is what's called the railgun, which can send a projectile at very high speeds, and it uses electromagnets to propel it. And the basic principle is you have your projectile, which may or may not be magnetic. You have some copper rails, and you have an armature which you put a current through, and this will move along the copper rails and push the projectile out, basically. And so sometimes this is attached to the circuit, and sometimes it's part of the projectile. They have varying ways of using it. And I've got a video called Railgun on the OneNote, which you can have a look at, one that's actually being designed, and I think they're almost ready to be put onto ships and things. They're thinking about it. A variation of the railgun, much larger variation of the railgun, is what's called the mass driver, which is using the same principle but over a much longer distance, and so objects would get a push due to the interaction of the magnetic field and current carrying wire, and because there's a force and it's accelerating, by the time it leaves the rail or the driver here, it should be well, the idea, hypothetically, is that it's travelling with enough velocity to actually escape the Earth, and so it's viewed as a way of potentially firing parcels and supplies and stuff needed for space into space without using rockets. It's theoretical. At the moment, I'm not certain if anyone's actually exploring it as an option, but clearly some people have thought about it, and people have thought about it as a way of actually using these mass drivers to shoot back ore from the moon. So this is the moon being mined. You refine what is, you might be mining rare earths or something else that's relatively rare on Earth, and then you process it and then you shoot it back to Earth without the need for rockets. So in the next video I'll look at some more applications. Cheerio.